in this video. Hello everybody, and welcome to the 57th video on the channel, and the second video in a bit over 3 weeks. Sorry, I was out for 3 weeks and I had just come back, so I just needed to catch up for a little bit. But yes, we are back with the second video after 3 weeks. In today's video's lesson, which we'll be explaining in a little bit, it actually builds right off the last one, so I definitely say it's very useful to watch the last one. And I think that's about it. Please make sure to like, subscribe, hit that notification button, and let's move on to the lesson. Today's lesson is about the double angle identities of sine 2 theta and cosine 2 theta. Now, these are actually very well known. You're going to see this throughout a lot of trigonometry and above. And these are pretty much stepping stones that pretty much everyone needs to know. Now, the reason I postponed this after I did a video about the addition of sines is because that the proof of that was necessary so you could understand how this could be proved. Because this is proved using that exact same formula, which we're going to get into in a little bit. And for cosine 2 theta, the thing with that is it's going to be proved with the cosine addition, but proving that is actually not as simple as the regular one, as the sine 2 theta, because it requires a lot of knowledge of vector algebra and matrices, which is not something we're going to explore just right now. So I will get into that proof eventually, but for now you're just going to have to trust me about the formulas that I've listed below in the proof. So I think that's all I have to explain. They're really good stepping stones, and you can see the formulas right on the screen. There's not too much to explain about them, besides that they're very useful, obviously. So I think it's better to get on right into the proof. The proof for each of the formulas is actually quite simple. Well, for sine 2 theta, what we're going to do is we're going to say sine, and then alpha and beta are going to be theta and theta. So sine theta plus theta, that's equal to sine theta cosine theta, because both alpha and beta are theta, sine theta cosine theta. Now, what you might notice is that they're exactly the same. So, what that does is that leads right into sine of 2 theta is equal to 2 sine theta cosine theta. So, that's the proof. It's actually quite simple, and I don't think there's really much more to explain to it. So now, if we go into proving cosine 2 theta is equal to the formula that was mentioned above in the lesson, we can go something like this. Cosine theta plus theta is equal to cosine theta times cosine theta minus sine theta times sine theta. So then what you do is then you just simplify, so you have cosine theta plus theta is obviously 2 theta. So then you have that equal to cosine squared theta minus sine squared theta. Now, there's also another way to represent cosine 2 theta, which is 1 minus 2 sine squared theta, and that's also very easy to prove from this. All you have to do for that one is turn cosine squared theta into 1 minus sine squared theta minus sine squared theta, because that's the whole expression, and then 1 minus sine squared theta is cosine squared theta. Because if you watch my introduction to trigonometry videos I did when I was in my geometry series, you'll know that I proved that cosine squared theta plus sine squared theta is equal to 1. So cosine squared theta is equal to 1 minus sine squared theta. So then this becomes cosine 2 theta is also equal to 1 minus 2 sine squared theta. And I think that's about it for this video. Thank you so much for watching, and see you in the next one. Bye-bye.